All right, so this is going to be Unit 4, Lesson 12, exponential graph. So let me just kind of refresh your memory. It's nice and short and sweet here. But when we have something that's in this format, we talked about this a little bit yesterday. This is your beginning amount. And because it's on a graph, we're going to say that that is going to be our y-intercept. This is what we call either our growth or decay factor. And I'll get a little bit more detailed in a minute. But that is what you're going to multiply each y value by every time. So it'd be something like this if I would make a table. I would start at 0 and I would start at 27. All right, then I would take that 27 and I would multiply it by 1/3. And so then I would get 9. Then I would go 9 times 1/3 and 3. So what's happening here is each of these y values is getting multiplied by whatever's right there. Now, how do you know if it's growth or decay? You always want to look at the b in your equation. Now, if that b is bigger than 1, it's growth. And if that b is between 0 and 1, it is decay. Now let's talk about horizontal asymptote and end behavior. End behavior is a new vocabulary word. What that means is as x increases, as your x values get bigger and bigger, what is your y doing? So a lot of times what you want to do is you want to look at the graph. So here's an example of the exponential growth. And here's an example of exponential decay. All right, so I highlighted the asymptote. If you remember the asymptote back when we did this lesson. So the asymptote is right here. It's the x-axis, which we also call this line y equals 0. So that's your asymptote. Your asymptote is really, really close to the graph. So let's look at this picture. As x increases, so as you're going out along the x-axis here, what's happening to your y values? So this one, your y is increasing each time the x increases. If we look at this one, though, what's happening to our y values? Our y is decreasing. It's coming down as my x increases. So that's what end behavior is. End behavior is saying what's happening to the end of the graph on either side here. Now let's talk about some shifts. So we're used to the equation y is equal to a times b to the x. And then what happened is we throw in some extra numbers. If there's a shift going on, and again, this was all taught to you during the second try. If there's a number up here and there's a number at the end, those are your shifts. So if there's a number right here, we're going to shift the problem left or right, but the opposite of what you see. Then if there's a number here at the end, that's going to shift it up or down, and it's exactly what you see. All right, so again, that was just lesson 12. You should be able to do those kind of problems now on your Khan Academy. You've worked with some polynomial graphs. You haven't worked with a bunch of them. The ones that you've been working with mostly are your quadratics. So this is a polynomial because we have an exponent of 2. Just as a quick reminder, a lot of this stuff is going to be reviewed, but some of it is going to extend into other ones. Anytime they say identify the zeros, that just means find the x-intercept, which just basically means solve. So if I have a graph here, this is a polynomial, and I find where x-intercepts are, let's say it's x equals 2 and it's x equals -3, those are what we call my zeros, or I can call those my solutions. Well, if I give you this problem, yes, you can type this in the decimals, and you can look and see where they hit the x-axis. But if you recognize this is already in factored form, so I can set each one of these equal to 0. And then if I solve this one, this is going to turn into 1/2, this is going to turn into -2, and this will turn into +3. So remember, the relationship between zeros and factors is their opposites of each other. You have to solve. If there's a number in front of x like this, I actually have to do a little bit more solving. So you have 2 ways to do that now. You can actually type it in decimals and look at the zeros, or you can, if you look at it real quickly and say, well, I already know these are factored, I can go straight into here. This is something new that you haven't been exposed to. Well, I shouldn't say that. You've been exposed to different pieces of this, it's just not all put together. So if they tell you that x equals -2, they're telling you that that is a solution. And then if we have a solution, that means that when we plug that solution into our equation, we will get 0. So I don't care what the problem was. Let's say it's this one up above. If I go ahead and plug in -2 everywhere that there's an x, I'm going to throw it into here real quick first. I know that -2 plus 2 is 0. 0 times this answer and 0 times this answer. Well, what's that going to give me? 0. So do I really have to bother doing the rest of it? No. However, if they throw in another number here, let's say like +7, then I would have to finish the rest of the problem. But because of the 3 parentheses side by side and that's it, I know my answer is going to be 0. Standard form. Standard form of a polynomial means no parentheses. Y-intercept, remember that y-intercept is always the last number as long as it's in standard form. So if I gave you something like this, this would be my y-intercept. But if it was the previous problem, if it was this, I can't just look at that last number and say that's my y-intercept. Yeah, let's talk about end behavior. We're going to talk about end behavior, although we did talk about end behavior just a second ago. I'm going to discuss it with between odd functions and even functions. So an odd function means that the highest exponent is odd. And an even function means that your highest exponent is even. So let me give you an example. If I gave you this, my exponent is 3. So let me show you what that graph looks like. So because there's a positive number out front, there's an imaginary 1 here, it's going to go in the upward direction, upward positive direction. But if I were to reverse it and call it a negative out front, it's still going to look like that, but it's going to be going downward instead. And I could have thrown in an x to the 5, an x to the 7. As long as the exponent here is odd, it's going to look like this. So let's talk about the end behavior. As x increases here, as I get bigger and bigger, what's happening to my y? My y increases. As x decreases, as I go further out this way, what's happening to my graph? It keeps coming downward. So then I'll say y decreases. And of course, this one's the opposite. As x increases, my graph is coming down. I'm going to say that y decreases. And then as x decreases, so as I go backwards here, my graph is going up. So I would say that y increases. Now with even functions, you've done problems like x squared, so we're not going to focus on that. Let's go ahead and do x to the 4th. X to the 4th looks very similar to x squared, except it's going to come across, almost going to look like it's going like an exaggerated U, not so much a parabola. And then if I have a negative out front, it's going to go the opposite. So this, as far as end behavior goes, as x increases, y, as I go out here, my y is going up. And then as x decreases, my y also increases. So no matter what, whether I go on the right side or the left side, as x gets bigger or smaller, my y, no matter what, will always go up. And then, of course, the opposite here. Now we're going to make some connections here. So we have zeros. We have zeros on 4 spots. So we have x is equal to -4. We have x is equal to 0. X is equal to 1, and x is equal to 3. So it says which one of these could be factors. Now factors mean that, remember, there'd be like parentheses around these. So factors, when you set the factor equal to 0, they should equal these solutions. So if I set this equal to 0 and solve it, will it give me one of these answers? Yes, this will turn into -4. So this is one of my answers. If I set this equal to 0, I'm going to get -3, but that's not a solution, so that's not it. Set that equal to 0, that will give me -1. Nope. Set this equal to 0, yeah, that gives me my second answer. Set that equal to 0, that will give me 1, that's my third answer. Set that equal to 0, that should give me 3, that's my fourth answer. And of course, that's not going to work. Then what I could do is I could go ahead and write this as a polynomial. X plus 4 is a factor, x minus 1 is a factor, x minus 3 is a factor. I could put that x anywhere. I could put it at the end, the beginning. I'm going to choose to put it at the beginning. Now, what's going to happen though? What if I were to go ahead and plug in, let's say -4? Oh, I plug in -4 into here. If I plug -4 into here, that's going to give me a 0. Well, 0 times anything will give me a 0. If I were to plug in 0 into the x spot here, 0 times anything is going to be 0. If I were to plug in 1, that's going to give me a 0. And if I plug in 3, that's going to give me a 0. So if I plug in any of my solutions, my answer will be 0. All right, and this one says we have x-intercepts. So if they're telling me we have x-intercepts, that means my x values are -2, 2, and 7. So how do we answer this question? It says which could be the function. These are all factors. So now I need to translate these to the factors. Remember, factors are the opposite. So if this says -2, this is going to turn into +2. This is +2, that will turn into -2. And that's 7, so that will turn into -7. So which one of these matches with these? This one. All right, so before I get into this one, let's just take a second and do a simpler one. So before I get into all that, let's look at something that we've done in the past. So let's say I gave you this problem. So we did this in synthetic division back in the first try. So that'd be a 1 here from here, a -3, and a -10. Then we set this equal to 0. We solve it. This gives us a solution of -2. So I put -2 up front. I bring that down. I'd multiply these together. Then I would add. Then I'd multiply those together. And then I would add. So notice that my remainder is 0 as long as that solution works. So then I would say that when I divided them, I'm going to put it back into a polynomial. I started with x squared. That means it's going to be 1x because I decreased the power, and then -5. There's my answer. So x squared minus 3x minus 10 divided by x plus 2 will give me an answer of x minus 5. And that is because I had a remainder of 0. So if you take something and you divide it by a factor and you get a remainder of 0, that means that that factor turns into a solution. So if I look at this, this is telling me that if x is equal to -1, this should be 0. But this is not saying that. That means that x equals -1, which would be turning into a factor as x plus 1. Of course, we're using t instead of x, so it's just t plus 1. That if this would be 0, this solution turns into this factor. But that's not the case because this doesn't say 0. So that means that nothing is going to be a factor. So I'm going to throw all of those out. This is saying that the remainder, when I divide something by t plus 1, is -7. So if they're giving me this as my answer when I plug it in, that means that that's my remainder. Remember that it's only equal to 0 if it's in fact a factor or a solution. And let's go back to a previous one. We said something is undefined when the denominator equals 0. But in the past, we did easier questions. So what makes this whole problem undefined is if this denominator equals 0. So if I set this denominator equal to 0 and try to solve it, there's two ways I can do it. I can go ahead and open up my Desmos, and I can graph it. And I would try to figure out where my graph hits the x-axis. No problem with that. But some of you that are pretty fast and quick at factoring may want to just factor it yourself. Another way we could do this is factor it. What multiplies for 12 and adds up to -7? So you might just go straight into those numbers right away. Those are the numbers that work. And then I can solve that. If I set that equal to 0, and set this equal to 0, my solutions are 4 and 3. You would have gotten the same thing had you actually graphed it on decimals. So what that means is if I were to plug a 4 into the x variable spot down here, I would eventually get 1 over 0 as my fraction, which is undefined. The same thing with a 3. If I were to plug a 3 in, I would get 1 over 3. Sorry, if I plug a 3 in, I would get 1 over 0. And again, that makes it undefined. So whenever they ask for something to be undefined, we're looking for what will make that be a 0 in the denominator.